In this session, I want to cover conversion between the two number systems. That is, convert binary to decimal and decimal to binary. So, we have already covered this part where in the first session, we covered the decimal number system where the base was 10 and then the powers were 1, 2, so on. And next we covered the decimal number system where the base was 2 and then the power of started from all the way to 0 to, and as we moved left it increased from 1, 2, 3 and so on. The important thing here is that I will be keeping focus on just 8 bits, bit number 0 to 7, in all 8 bits. And the reason I'll be focusing only on 8 bits is because when we are talking about IP version 4 addresses, that is made up of 32 bits, and 32 bits is divided into 4 equal parts and each of the part is 8 bits. So as long as we have a good grasp on the 8 bits, then we should be good. Okay, so moving on. So when I say 8 bits, so these numbers 1, 2, 4, 8, 16, 32, 64 and 128 become very vital in understanding how the IP addresses work. So as quickly as you get a good understanding of how these numbers play along with each other, the IP address topic would be very easy for you. So please pay attention when we are discussing this topic. Okay. So the same numbers here I have put in a tabular form. On the rightmost part, if you see the base position, the position 0 gives 2 to the power 0 and the corresponding value 1. So I've given the detail of the position, bit position 1, 2 raised to the power 1 and underneath that 2. So 2, bit position 2, 2 raised to the power 2 and the corresponding value 4 and so on, right? Now, always remember that again, I am trying to push this and solidify the concept here that the bit position is important and the corresponding value is important. So if a particular value exists, either 0 or 1 exists on the bit position 0, it needs to be multiplied by 2 raised to the power 0. If coefficient 0 or 1 exists on bit position 5, then it needs to be multiplied by 2 raised to the power 5 and so on. So just pause here, go through it and digest this, and once you have got a hold of it, then move on. Okay, so and once these are multiplied, all we need to do is add them up to get the decimal equivalent. So this is what it is. Now I have picturized it, depicted it in either 2 raised to the power base. If you see in the green sentence written, multiplied by either 1 or 0. 1 or 0 is because depending on what is the coefficient of that corresponding value, okay, of that bit position. Or instead of writing 2 raised to the power 0, which is equal to 1, or 2 raised to the power 2, which is equivalent of 2. So I've just written here the equivalent values: 1, 2, 4, 8, 16, 32, 64 and 128. Or put it in the tabular format like this. So far nothing, just don't get confused, but just try to understand the concept that how we can write 2 raised to the power 0 in terms of 2 power of 2 or just the numbers. That's what I have covered till now. Okay. Now let's take the first example. We have put the binary number 100 10111, the one that I have put in red, and this is the number that we want to convert into decimal. Okay. So all we do is take these numbers, as I said, read the sentence in the green, multiply either by 1 or 0. So what does 128 get multiplied by? It gets multiplied by 1 because that is the corresponding value, coefficient. Okay. So And what does 64 get multiplied by? It multiplies by 0. 32 gets multiplied by 0, 16 gets multiplied by 1, 8 gets multiplied by 0, 4 gets multiplied by 1, 2 gets multiplied by 1, and 1 gets multiplied by 1, like this. And then whatever is the outcome of the multiplication, we write it down here like this. Whatever we find as 0, we put it 0. And then finally we add them up together. And that is what gives us the equivalent decimal number. Okay. Now, this was binary to decimal conversion. Now let's calculate binary from decimal. So we'll take two examples. The first one being, we'll put the binary decimal number at the bottom, 65, and let's see, go about it like this. So 65 is smaller than 128, right? So we definitely don't need 128. Now in terms of when I'm putting these values, I'll say I'll either 1 or 0 or on or off. On is same as 1, off is same as 0. Okay. So I'm going to set the 128 bit because 65 is smaller than 128. We don't need 128. So I'm going to set it to 0 or turn it off. Now 65, next I compare it with 64. So 64 is definitely, 65 is definitely bigger or larger than 64. So that's why we definitely need 64. And hence I'm going to turn it on, set it to 1. Okay. That leaves me with 1. Now, if you look at the whole thing, where exactly is, do I need 32, 16, 8, 4, 2? No, right? All I need is another 1. So what I have to do is set that 1, the rightmost bit position to 1. So corresponding to 1. So and if you think in our mind, it is as simple as this. 1 into 64 plus 1 into 1. That gives us 64 plus 1, 65, right? So that is, and then I'll set the remaining bits to zeros and then get what? This is what my equivalent binary number is. 65 converted into binary is 0, 1, 0, 0, 0, 0, 0, 1. Okay. Let's take another example. Okay. Here I'm putting 156. I have to convert 156 into that. So same, using the same method as we use for 65. Let's convert 156 into binary. Now what is 156 is definitely bigger than 128. So we definitely need 128. So I'll turn it on, set it to 1, and then see what is the remaining. Since I've already turned on 128, what is the remainder? 156 minus 128. That gives me 28. Now this 28 I compare with the next number, which is 64. Do I need 64 for achieving 28? No. So I turn it off. I compare it with 32. Do I need 32 to achieve 28? No. So I'll turn both of them as off, zeros. Okay. Then I compare 28 with 16. So 28 is definitely bigger than 16. So I do need 16. So I'll set it to 1. Okay. Now compare. Now what is remainder? 28 minus 16. That is 12. Now 12 I compare with the next one, which is 8. Is 12 greater than 8? Yes. So that's why to build up 8, I need the 8. So I'll set it to 1. Okay. Now what is the remainder? 4. And this 4 I need to compare with the next number, which is on the right side, it is 4. So 4 is equal to 4, and hence I definitely need 4. So if you see this is what I get. Now this can be, and finally I'll set the remaining two to zeros. Okay. Because I have already achieved what I wanted to do. So if you look at the equation, in my mind, it is one time, I need 128, 16, 8 and 4. If I add 128 plus 16 plus 8 plus 4, it gives me 156. And hence, the coefficients for all of these, that is 128, 16, 8 and 4 need to be 1. Others need to be off or set to 0. Okay. So it is as simple as this. This is how I validated. This is the number that I wanted, and so the corresponding binary number is 1001100. Okay, that's a binary equivalent of decimal 156. All right. I want to end this session by giving some simple questions in quiz for you to try it out. Okay, so try out these and see if you can do this comfortably. If not, come back and revise this and you should be able to complete that. Okay, convert 127 to binary, convert decimal 15 to binary, convert decimal 52 to binary, and for a change, convert binary 100,100,11 to decimal. Try these out, and if you are able to successfully complete these, then you can say that you have a good grasp of the topic.